All right, so the last two shapes for quadrilaterals that we have to talk about are trapezoids and kites. So a trapezoid is a quadrilateral, so it means four sides, with exactly one pair of parallel sides. So there's only one. The parallel sides are called the bases. The non-parallel sides are called the legs, just like on an isosceles triangle. The base angles are formed by the base and one of the legs. So there's two pairs, bottom base angles and top base angles, or upper base and lower base. If the legs of the trapezoid are congruent, it's called an isosceles trapezoid, very similar to an isosceles triangle. And the upper base angles are congruent, the lower base angles are congruent, and the diagonals are congruent to each other. So there's one actual mathematical formula that's associated with trapezoids, and it's something called a midsegment. So the midsegment, it's like the middle. It's the middle segment between the two bases. So how you find it is you're taking the average of the bases together. So if we look at this shape right here, here's our two bases, AF and CD. So this is base 1, CD is base 2. This middle guy right here, this is the midsegment. Well, think again, it's like the average. So what I'm going to do is I'm going to add up AF and CD, and then when you take the average, you divide it by how many you have, which is 2. And that's going to get me BE, which is the midsegment. So it's the average of the two bases put together. So if we look down here, here is my midsegment. So that means that MN is equal to my two bases. Here's B1, here's B2. So it's QR plus TS divided by 2. So X equals 35 plus 20 divided by 2. So that's 55 divided by 2, which gets me 27.5. That's the average of those two, and that would be the length of that midsegment, which is right in the middle there. All right, let's try another one. Difference here is I have the midsegment. So still going to create my formula. So LH is equal to FG plus KJ divided by 2. LH, though, is 15. FG is my X. 18.2 is my other. And I'm going to divide by 2. So I'm going to make a proportion. Cross multiply. The only thing that's getting affected is the 15 times the 2. The X is going to stay where it's at, and then I'm going to subtract 18.2 on both sides, and I end up with 11.8. The nice thing is, plug it back in and make sure it actually works. Do 11.8 plus 18.2 divided by 2 and see if you get 15 for that. All right, second shape is a kite. So a kite is a quadrilateral with exactly two pairs of consecutive sides being congruent. But unlike a parallelogram, the opposite sides of a kite, they're not congruent to each other and they're not parallel. So again, it says a kite is a quadrilateral. It does not say that it's a parallelogram. Other properties is that the diagonals are perpendicular and that exactly one pair of opposite angles is congruent to each other. Okay, and it's sort of like the mirror reflection on both sides. So example 2 says if F, G, H, and J is a kite, we want to find G, F, J. So we've got our figure. So what I'm going to do is I'm going to actually, I don't know what the other two angles are, but these are the two that are going to be equal to each other because, again, if I drew this down the middle, it's like a mirror reflection. But I'm going to give them both X's. Now, from the first section in this chapter, this is a four-sided figure. So N is equal to 4. Well, if I'm going to use the sum formula to figure out what all the interior angles equal, that's my N minus 2 times 180. So 4 minus 2 times 180 is 2 times 180, which is 360. So I know that X plus 128 plus X plus 72 is equal to 360. So I get 2X, 0, 1, 0, 1, 200 equals 360. So 2x equals 160, which means x is 80 degrees. And that is the angle that we're looking for, which is GFJ. Okay, so you can use a lot of your prior knowledge for these. Now for the third one, it says that it's a kite and we want to find ZY. Okay, well, we know that diagonals are perpendicular, so we're going to add our right angles in there. And we're looking for this. So this is where our Pythagorean theorem comes in. I'm taking this triangle out of the figure and I'm redrawing it. So I have 8, 24, and x. So if I do a squared plus b squared equals c squared, I know my a and my b. I don't know my x value. So I get x squared equal to 640 when I combine. And then when I take the square root, I get x equaling about 25.3 for that final value. All right, we got a kite here. So it says BAD is 38. So 38. BCD is 50. Oop, that whole thing's 50, which I know it gets cut. So I'm going 25 and 25. And I want to find ADC. So if that's 38, I know this guy's 38. And I'm looking for this angle right here. Okay, so I can do the same idea. Again, it's got 4 sides. So I know the sum is equal to 360 because any 4-sided figure equals 360. Again, you can use that formula n minus 2 times 180, but not needed. So this is x and this is x. So I know that x plus 50 plus x plus the 2 38s are going to equal 360 degrees. And when I solve that down, I find out that my angle, which is x, ADC, is going to be equal to 136 degrees for that. Now, for the second one, though, now we're focusing diagonal based here. Green, I guess we'll say. So it says if BT is 5 and TC is 8, and we want to find CD. Well, if BT is 5, then TD is 5. We know the diagonals are perpendicular, so this is, again, a Pythagorean Theorem situation where I'm going to take out the triangle. I've got 5, 8, and x. So I've got 5 squared plus 8 squared equals x squared. X squared comes out to 89, and then when you take the square root, x is equal to 9.43 for that final answer. Now let's do 7 before we jump back into a trapezoid here. So we have another kite and we want to find C. Well, if this angle is 85, I know this angle is 85, and here's my x. So again, n is equal to 4, which means the sum of the angles is 360. So 85 plus 120 plus 85 plus x equals 360, which when I solve, x is my angle C, which is going to be equal